Hi guys. Okay, so today we are starting with a new topic, new trimester. Topic is systems of equations. Systems of linear equations. Technically, I could have put that in there. So let's talk about what a system is. So in your notes, go ahead and write, what are systems? Okay. So systems are two or more equations, two or more equations that have one comma, none, comma, or infinite solutions. Two or more equations that have one solution, no solutions, or infinitely many solutions. Okay, so a system, they kind of like work together. They're part of a family, part of a team, however you want to think of it. So I'm going to have you kind of just show yourself an example. This is a completely fake example, but let's do a linear equation like x plus 2y equals 19. Notice that's in standard form, just something to think about. They don't always have to be in standard form, although a lot of the time they are. They could also be in slope-intercept. So this next equation could be y equals 2/3 x minus 1. But how we know they're in a system is it would either tell you, like, in this system of equations, blah, blah, blah. Or if it simply goes like this, it has this little grouping symbol around it. It's just kind of a curly brace, it's called. If they're grouped together like that, that just immediately tells you that those two equations, they are working together in a system of equations. Okay. So that's just like what it is, all right, what it looks like. But now let's talk about when we would actually use a system rather than just a regular equation. So when to use systems. Let's go ahead and write that down. When to use systems. If you have one or, excuse me, typo. If you have more than one unknown amount. If you have more than one unknown amount, you must set up a system. Set up a system to solve for the unknowns. Okay, so if you have more than one unknown thing, you have to set up a system or else you won't be able to solve for more than one variable. So I'm going to show you just kind of what I mean by unknown things. So if you had, like, we'll do examples. If you have one unknown amount, I'll show you what that looks like. Two unknowns, and we'll do three unknowns. So when I'm talking about unknowns, I'm talking about variables. When you see a variable, it stands for an unknown number. Sometimes that number can like change, like if it's in a linear inequality or equation. But sometimes that number is fixed, like it's a specific amount that you're trying to solve for. So we've seen examples like this. You've seen examples way back in 6th grade. If you had like 2x equals 10, there's only one variable's x, which means there's only one unknown. There's only one thing that you are solving for. So if you were to solve that, what would you get for x? 5, right? Divide by 2 on both sides, you get 5. Now let's say you have 2 unknowns. So maybe we have 2x plus y equals 10. Now you have an x and a y. This looks familiar. Recently, we've done standard form, but x and y could be many different things, except if I have another equation that relates x and y, then x and y are very specific amounts. So, for example, like if you were to plug in a 1 for 2, then that y would have to be 8. 2 times 1 plus 8 is 10. That's a true statement. If that x were to be 5, plug in a 5 there, then the y would have to be 0. 2 times 5 plus 0 is 10. So right now, x and y can be a whole bunch of things, and that's because if you were to graph it, it'd be like one single line. But if I put another equation relating that x and y, that changes things. So if I have negative x plus 3y equals negative 12, now if we were plugging those fake answers for x and y down here, they might not work anymore. It might not make sense. It might not equal negative 12 when you plug them in. So it's a very specific x and y value that you would have to solve for. And that's what we're going to be doing in the next month, is learning how to solve for 2 unknowns. That's pretty big stuff. We've been solving for one variable for a long time. Now you guys are going to get into solving for both x and y. Okay. Now, you're not going to do this in my class, but in Algebra 3-4, you will be solving for 3 unknowns. So x, y, and by the way, they don't always have to be x and y. You could be solving for k and solving for w. Doesn't matter. But 2 variables. But in Algebra 3-4, you'll be solving for 3 variables, and that's typically x, y, and z. So we're just going to have a little example of that. So like 5x minus y plus 2z equals 27. X equals 3y plus z. Z minus 3 equals 3x plus y. So notice all of those equations have x, y, and z, meaning there's 3 unknowns. So here's what I want you to really understand. If you have 1 unknown, that's not a system. That's just a regular equation. That's the type of equation you've been solving for years now, okay? If you have 2 unknown amounts, you have to set up a system in order to be able to solve for x and y. If you were to have 3 unknown amounts, you would have to have 3 equations in a system, okay? So if there were 6 unknown amounts, 6 different variables, how many equations would you have to have? To have 6 equations within a system, okay? But we're only focusing on 2 unknowns, okay? So let me give you an example of when, or it's going to be a word problem, by the way, of something with like 2 unknown amounts, okay? So this is going to be the only, well, I shouldn't say that. You might be doing a lot of writing today, okay? All right, here's your first example. Megan, yes, please write this down. Megan bought 2 Kit Kats. If you don't know what those are, they're candy bars. Megan bought 2 Kit Kats and 1 bag of Takis. If you don't know what those are chips, which are super spicy, for me at least. 1 bag of Takis for, and then here's how much she spent, for $4.85. So she bought 2 Kit Kats, 1 bag of Takis for $4.85. So right now, we know how much she spent, but like, I don't know the price of a Kit Kat, and I don't know the price of a bag of Takis. I just know how many of each that she bought. So technically at this point in time, there are 2 unknown things, okay? So in order to know how much a Kit Kat is and how much a bag of Takis is, I would actually have to have more information about this situation. So here's your more information. So along with Megan in the same store is her friend Enrique. Enrique bought 1 Kit Kat and 3 bags of Takis. Oops, no, period. 3 bags of Takis for, and then we'll say what he spent. He spent $7.80. So he only bought 1 Kit Kat, but he got 3 bags of chips for $7.80. So the question is, what is the price? What is the price of a Kit Kat? And what is the price of a bag of Takis? Okay, so this would be an example of a word problem where you're looking for 2 unknown amounts. So the only way to solve for it is to set up a system. So we're actually not focused on solving, like today in my class, you don't actually know yet how to find the price of each of those. But we'll be learning that over the next month. Today is focused on how do we take a word problem like this and how do we just set up a system. Okay, so here is my advice, and keep in mind when I give you some advice, try it out. Try it out. If you can find a better way, then cool. But try out my advice. Here's my advice. When I'm setting up a system of 2 equations, 2 or more equations, I always look for the total amounts. So in your word problem, you're going to hopefully have 2 amounts in there that are considered totals. So I recommend circling the totals. And then any other thing that's probably important, let's underline. Okay. So I'm going to read through this. Megan bought 2 Kit Kats and 1 bag of Takis for $4.85. I see the number 2. I see the number 1. I see $4.85. Which one of those is a total? Well, the total she spent was $4.85. I'm going to take that total right now, and I'm going to put that, I'm going to have blah, blah, blah equals, and then her total, $4.85. Okay. You don't need the dollar sign. I just put it just because. Okay. 2 Kit Kats, though, that's still important. And 1 bag of Takis, still important information. I'm going to keep reading. Enrique bought 1 Kit Kat and 3 bags of Takis for $7.80. So once again, I'm going to have you circle the totals. 780 is another total. That's going to be the total for the second equation. Okay. And his important information is 1 Kit Kat, 3 bags of Takis. Okay, so when we're building this equation, we have to know what goes over here. Well, first of all, we should probably define our variables, meaning we can use X and Y, or you could use K for Kit Kat, and you could use T for Takis. Let's do that. Let's use K and T on this one. So K and T. What is K though? Amount of Kit Kats, price of Kit Kats, you got to be specific. So in this case, we're looking for price. So I'm going to go like this. I'm going to do money sign, but you could write price of, and then I'm going to write Kit Kat. So how much a Kit Kat costs is K. T is going to represent how much a bag of Takis costs. All right. Another thing to do is let's talk about what these total amounts are. What is $4.85? Whose total is that? That's Megan's total. And the $7.80 was Enrique's total. Okay. Now in this first equation, if this first equation represents Megan's information, I should probably include the amounts of things that Megan bought. She bought 2 Kit Kats. The number 2 is probably going to be in my equation. She bought 1 bag of Takis. but I need some variables in there. Which one of these numbers do you think the K goes right next to? 2 Kit Kats? 2 times K. 1 bag of Takis? That's going to be 1 T. And you could also just write it as T. You could put a 1 in front of it, right? Same thing. So 2 Kit Kats, 1 bag of Takis, and her total was 45. Hopefully that makes some sense. See if you can write Enrique's statement, okay, his equation. He bought 1 Kit Kat, so you could write 1K or just K plus 3 bags of Takis. 3 Takis. That's it. That's all you're doing. We're not focused on solving because I haven't taught you how to solve. Today, I just want you to look at a word problem and figure out how to set it up as a system, okay? So you're gonna have 2 variables, figure out what those variables are and what they mean. And then I recommend circling your totals and putting those at the ends of your equations, okay? So I have 2 more for you. I typed mine up because I didn't want to spend 5 years writing this down in the video. So here's what I'm going to recommend though. If you want to pause the video and actually like write it down, I think that would be smart. But at a minimum, you need to like hear me talk through it and then try and write the system of equations yourself, okay? So feel free to pause the video, write this down, or at least try and write down the system for it, okay? So here we go. A group of 42 juniors went on a college visit to WSU. Each student was gifted either a t-shirt or a water bottle as a souvenir. So they got it for free. T-shirts were $18.50 each. Water bottles were $15.25 each. If the total price of souvenirs was $731.50, how many t-shirts and how many water bottles were gifted to the students? Okay, so right down here, it tells us what we're looking for. How many t-shirts and how many water bottles were gifted? So t-shirts, water bottles. You could use T for t-shirts. You could use W for water bottles. You could use X and Y because you love X and Y. So I'm going to show you that X and Y are completely acceptable. Okay, you could use T for t-shirts, W for water bottles if that helps you keep it straight in your head. Okay, so I'm going to say that X is number of t-shirts. And I'm going to say that Y is the number of water bottles. Okay. All right, now I'm going to go through and I'm going to circle my totals. And it might not be money, totals. A group of 42 juniors went on a college visit to WSU. 42 of them. You think 42 is going to be in this equation somewhere? It is. It's the total amount of students, okay? And if each student is getting a souvenir, if each student is getting a gift, then there's actually 42 items that are being given out, okay? All right, each student was gifted a t-shirt or a water bottle, so 42 items were given. T-shirts were $18.50, water bottles were $15.25 each. So those are not totals, but they are important. And then if the total price of souvenirs was $731.50, how much of each item were given? Okay, so our 2 totals are going to be the 42 and the $731.50. Okay, now what are those totals of though? The 42 is how many students were on the trip, but in this case, it's also the amount of items that were given. So I'm going to say total number of items. Okay. And $731.50 was like the total cost. So I'm just going to do a $sign once again. Okay. Now, to me, this last one it makes sense that it's the money statement. So you're going to have money plus money equals money, right? So I'm going to actually do that one first. T-shirts were $18.50. So $18.50 is going to be part of my statement. But what does the $18.50 go along with? Does it go along with X or Y? T-shirts were $18.50. So that $18.50 gets multiplied by X. And we're going to add it to the water bottle information. Water bottles were $15.25. So that gets multiplied by Y because Y is the water bottles. Once again, if you use T and W instead, it would be 1850 T plus 1525 Y. Okay. And then what the heck do we put up here? I know X and Y have to go in there. I'm just not sure if something gets, multiplied by X and multiplied by Y. So let's just see what happens if we put it like this. What is X? Number of T-shirts plus number of water bottles. Is that going to equal 42? Yeah. If 42 students went on the trip and each one of them gets a gift, whether it's a T-shirt or water bottle, that's going to be 42 gifts, 42 souvenirs. So the number of T-shirts plus the number of water bottles is going to be a total of 42 items. Okay. So that's it. All we're doing today, setting up systems. I put that little thing to show that it's actually a system. They work together. Okay, so number 3, same sort of thing. I printed it off, but you are going to try and write the system as a little practice question. Okay, so you're going to enter your answer on Delta Math underneath this video. There is a little practice question and you're going to try and choose which system is correct for this. Okay. Okay. Miss Meineke tells you that the next test has 12 questions and is worth 40 points. Multiple choice questions are worth 2 points each and word problems are worth 4 points each. How many of each type of question are on the test? So I'm going to give you a little bit of guidance. Let's look for our totals. 12 questions, 40 points. Those are both totals. There are 12 questions on the test. It is worth 40 points total. The 2 and the 4 are the amount of points per type of problem. Okay. So I'm gonna have you fill in these on your own, but let's make sure we're all using the same variables here. We will use M and W. So M is number of multiple choice questions. And W is the number of word problems. Okay, so you are trying to fill in the blank over here. So that's what you're going to enter in on Delta Math. Okay, good luck. Thanks, guys.